Hello guys, how are you? We have question 4. It says 3 capacitors X, Y, and Z are connected as you see in the opposite circuit, okay? Now, if the switch S is closed, calculate first the equivalent capacitance. We notice here that capacitor X and capacitor Y are connected in parallel. It means I can find the C parallel is going to be 6 plus 2, which is 8 farad, right? Now, the 8 farad with the Z connected in series. So I find the C total is going to be of course C parallel 1 over C parallel plus 1 over CZ. So it's going to be 1 over 8 plus 1 over 12, of course to the power minus 1, okay, which equals to 4.8 farad. Okay, this is part A. Now, they want the electric charge stored in the circuit. The charge stored in the circuit. The charge, I know it is Q equal CV. Since they want the charge in the circuit, so it is Q total, okay? So I'm going to use the C total, okay? And the V of the battery, let's call it also V total. So this will give me Q equals C. We found it before right here. It is 4.8 multiple. The V, it's 24, which will give me 115.2 coulomb. Okay, so this is the total charge, or the charge stored in the circuit. Okay, I have part C. It says find the electric charge stored in capacitor Z. Okay, they need the charge stored in Z. Pay attention guys here that Z right here, it is connected in series with the battery. Okay, which means that the battery given by the charge given by the battery, sorry, it's the same charge that is going to be in Z. Okay, so I can say that here the charge stored in Z is actually the same total charge, okay, which we found it before. It is 115.2 coulomb. Why is that? Again, because the capacitor Z is connected in series with the battery. Now they want potential difference in capacitor Z. Okay, let me go back here. Okay, so this is the Z. I have the capacitance and we just got the charge. So simple, I can find potential difference. Okay, so the voltage in Z is going to be Q over C. Q over C, which QZ, which is Q total, and C is CZ. Okay, so the Q is 115.2 and the Z is actually 12 farad. Okay, I get 9.6 volts. 9.6 volts. This is the voltage in the Z capacitor. Now in part E they want potential difference in across capacitor X. Let's go back to the circuit. Okay, they want the voltage in here, Vx. Notice here that as I said at the beginning that X and Y are connected in parallel, okay, which means they have the same voltage. Okay, here I have Vy, Vx and Vy are the same. Okay, let me call them V1. Okay, why the same? Because of course they are in parallel, right? Okay, so I will write here Vx equals Vy, which equals the V1, which is the voltage in the parallel combination. How to get the V1? It's actually the total voltage minus the voltage we found in the Z. Okay? Why is that? Because basically, guys, the Z capacitance is connected in series with the parallel combination. So let me go down here. Let me write. So the voltage of the battery, it will be the VZ plus the V parallel. Okay, guys? This means that the V parallel, I take the VZ to the other side, it will be V minus V Z, okay, which will give me, which is actually 24 minus 9.6, okay, which equals 14.4. So this is what, this is again, this is the voltage in the parallel combination, which is the same as the voltage in X, which is also the same as the voltage in Y. Okay, I hope it's clear. Let me go back. I want to repeat what I said. So the X and Y connected in parallel, so they have the same voltage. Okay, let me erase blah 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 everything here, because we need to keep this area clean in order to solve the other parts. I guess we still have many parts. So now we just did the part E. Now part F, it says we need the potential difference across capacitor Y. We just got it, because we agreed that the V in capacitor Y is actually the V in capacitor X, which is the V in the parallel combination, okay, which is 14.4. This is it. Of course, it's volts. Okay, guys? I hope it's clear. Now we go to part G. They want electric charge stored in capacitor X. So they want me to find Qx. Okay? We know that Q in general, it is C multiple V, right? We have the C of X, it is 6, right? Multiple. The Vx, this is multiple, this is not X, okay? The Vx, we just got it. It's right here, okay? It's the 14.4, right? So it's very simple. 6 multiple 14.4. I get 86.4 Coulomb. Okay, this is the charge in X. Good. Now they want the electric charge stored in Y. I can do the same thing. Q in Y is actually CY multiple VY. This is Y. Okay. The CY, how much? It is 2, as I remember. Oh, let me go back here. Yes, it is 2 farad. So multiple Vy, we just got it here, okay, equal, it is 14.4, which will give me 28.8. 28.8. Okay. Of course, I can find the Qy in another method. The Qy is actually the total charge, okay, minus the Qx, because X and Y are connected in parallel, right? So it's going to be 115 minus 2, 0.2 minus the 86.4, okay, which will give me, let me use my calculator. I guess it will be, so 115.2 minus 86.4, it gives me, what's this? Oh, instead of writing 86, I wrote 68. I'm sorry. Okay, 86. Yeah, I got 28.8. Basically the same answer. Remember, this is Coulomb and this is Coulomb. Okay, this is H. Do we have? Oh, yes, we have. Oh, we have here the I. They want electric charge stored in Z. Basically, this question is the same as, I guess, as C. We did this already. Let me go back to the part C, A, B, C. Yeah, we just did that before. It's a repeated question. Now, energy stored in the circuit. They need energy stored in the circuit. E equal half CV squared. Okay, C total and V total. Okay, which is going to be half multiple C total. We found it 4.8 multiple the total voltage of the battery. It's 24 squared. The answer will be 1382.4 joules. This is the total energy in the circuit. Now part K, let me change the color to this one. Yeah, in K they need energy stored in the X. I apply the same formula, E equal half CV squared. Of course, C of X and V of X, and I have both of them, so it is half. Capacitance of X, guys, it is 6 multiple the voltage of X. We found it 14.4 squared. So the energy in X is going to be 622.08 joules. Okay. Now, I guess this is, oh, no, it's not the last one. They need energy in capacitor Y. Let's do the same thing. Energy in Y is actually half C V squared. Which C? It's the C of Y and V of Y. Okay, so it is half multiple 2 multiple 14.4. Again, it's the same voltage in X because they are connected in parallel. And the answer will be 207. This is 0, sorry, 0.36 joules. This is the energy in Y. Okay? Now, energy stored in capacitor Z. They need energy in Z. I will use the same thing, CV squared. It's the C of Z, V of Z, which equals half multiple 8. Oh no, 12. Sorry, this is 12. Multiple, how much was the voltage in Z? It was 9.6 squared. Okay, and the answer will be 552.96 joules. Oh God, please say it's that. Oh God, alhamdulillah, that's the last one. Okay, I know it's a long question, but as you can see, very simple steps, very simple solution. Okay, if you have any question, guys, please leave it under the video. Okay, let me go back here. Okay, and then I will say bye bye. Have a great day. See you.